In our previous session, you have studied that carbon is an inseparable element in human life as we use innumerable number of carbon compounds in our day-to-day life. This is because the food we eat, medicines we take when we are ill, the clothes we wear, domestic and automobile fuels, paint, cosmetics, automobile parts, etc. that we use contain carbon compounds. But how have these been made? Let's get started on this exciting topic with me, Shubhajit, and today with me is Hemalata. Learning outcomes. At the end of this session, you'll be able to understand about bonding in carbon compound, different hybridization in carbon compounds, sp3 hybridization, sp2 hybridization, sp hybridization. Keywords are covalent bond, hybridization, single bond, double bond, triple bond. Before starting, let's look at this concept map for this session. Our first topic is bonding in carbon compound. Carbon is a non-metal element. It belongs to 14th group or 4A group in the modern periodic table. The elements of this group have 4 electrons in the valence shell. The atomic number of carbon is 6. This is the electronic configuration of carbon when it is in ground state. To attain the configuration like nearest noble gas or stable element, helium, either carbon needs to leave 4 electrons or it can take 4 electrons. As carbon has only 6 protons in nucleus, it would be difficult for 6 protons to hold 10 electrons. Hence, carbon cannot form C4- ions. If carbon loses 4 electrons from the outer shell, it has to form C4+ ions. This requires huge amount of energy, which is not available normally. To get the helium-like configuration, carbon has to form 4 covalent bonds, either with its own atoms or atoms of other elements. The possibility of bonds formation by a carbon atom is as follows. 4 single covalent bonds with atoms of same element like hydrogen and chlorine, or 4 single covalent bonds with atoms of different elements. Carbon atoms may form 1 double bond and 2 single bonds. Carbon atoms may form one single bond and a triple bond. How do carbon atoms form bonds in so many different ways as mentioned above? Here you can see the electronic configuration of carbon atom in its ground state, which is 1s2, 2s2, 2p2. In excited state, carbon atom gives one of its 2s electrons to the 2p. Each carbon atom has 4 unpaired electrons, and when excited, they tend to form 4 covalent bonds. But there is a question: where does energy come from that is required to excite the carbon? When bonds are formed, energy is released and the system becomes more stable. If carbon forms 4 bonds rather than 2, still more energy is released, and so the resulting molecule becomes even more stable. The energy difference between the 2s and 2p orbitals is very small. When carbon atom is ready to form bonds, it gets a small amount of energy from bond energies and gets excited to promote an electron from the 2s to the empty 2pz to give 4 unpaired electrons. The concept of hybridization was introduced by Linus Pauling, 1931. The redistribution of orbitals of almost equal energy in individual atoms to give equal number of new orbitals with identical properties like energy and shape is called hybridization. The newly formed orbitals are called as hybrid orbitals. In the excited carbon atom, its 1s orbital and 3p orbitals intermix and reshuffle into 4 identical orbitals known as sp3 orbitals. Thus, carbon atom undergoes sp3 hybridization. The 4 electrons enter into the new 4 identical hybrid orbitals known as sp3 hybrid orbitals for 1 each. The hybridization enables the carbon to have 4 identical sp3 hybrid orbitals, and these have 1 electron each. Since carbon has 4 unpaired electrons, it is capable of forming bonds with 4 other atoms. According to valence bond theory, when a compound has sp3 hybridization, the structure will be tetrahedron. Let's take an example of methane. In the nucleus of methane, the central atom carbon is at the center of the tetrahedron. See figures. This leads to the formation of 4 sp3 s sigma bonds between carbon atom and 4 hydrogen atoms. All these bonds are of equal energy. How do you explain the ability of carbon atom to form two single covalent bond and one double bond? This will be explained in sp2 hybridization. Consider the ethylene molecule as an example. It is the intermixing of one s orbital, 2s, and 2p orbital, say 2px, 2py, and reshuffling it to form 3 sp2 orbitals. Now each carbon atom is left with one p orbital, say pz, unhybridized. The 3 sp2 orbitals having one electron each get separated around the nucleus of the carbon atoms at an angle of 120 degrees. When carbon is ready to form bonds, one sp2 orbital of one carbon atom overlaps the sp2 orbital of the other carbon atom to form sp2 sigma bond. The remaining two sp2 orbitals of each carbon atom gets overlapped by s orbitals of two hydrogen atoms containing unpaired electrons. The unhybridized pz orbitals on the two carbon atoms overlap laterally as shown in figure to form a pi bond. That means there exists a sigma bond and a pi bond between two carbon atoms in ethane molecule. This time we are talking about sp hybridization. This time they use the s orbital, 2s, and one of the 2p orbitals, but leave the other 2p orbitals unchanged. The new hybrid orbitals formed are called sp hybrid orbitals because they are made by an s orbital and a p orbital, reshuffling it themselves. Let's take acetylene as example. In acetylene molecule, there exists a triple bond between two carbon atoms, and the fourth valency of each carbon atom is satisfied by hydrogen atoms. This is the hybridization of acetylene molecule. Our next topic is hydrocarbon. The organic compounds that are composed of only carbon and hydrogen atoms are called hydrocarbons. Hydrocarbons are further subdivided into three classes such as alkane, alkene, and alkyne. These are hydrocarbons which contain only single bonds. They are represented by the general formula CnH2n+2, where n equals to 1, 2, 3, and so on. The simplest alkane when n equals to 1 is methane, CH4. The hydrocarbons which contain one or more C double bond C bonds are called alkenes. These are unsaturated compounds. They are represented by the general formula CnH2n. The hydrocarbons containing carbon to carbon triple bond are called alkynes. They are also unsaturated as they contain triple bond between carbon atoms. They have the general formula CnH2n-2.